Welcome to E-Yantra Technologies. This is experiment number 2 of R20 ECE Jntuk Regulation 20 Arduino and ARM based lab. In the second experiment we are going to study the PWM, pulse width modulation. In the folder provided to you, you have 4 different types of waveforms generation using pulse width modulation. You can see the fading effect, you can see lamp flicker, ramp wave, and pulse width modulation with pot. You can choose any one of them. For all of them the process is same. I'll show you the PWM with pot. Just open the sketch and follow the same procedure that you have adopted for the previous experiment number 1. You can refer to the previous video. Just like the same, you select the ports, you select the board, and then you select the appropriate processor and then hit upload. So this is the code provided. As usual, you just go to tools, and then select Arduino Nano processor at Mega 328P, and whichever COM port you got, just select that one and then just go with the code here. Here we have pin 3, which is by default pin 3. The D3 is the pulse width modulation supporting pin. You can see here it is mentioned here as a D3. D3 is supporting the PWM here. So if you want to use any other pin, you can remove the clip and you can use the other. But on Arduino Nano there are only 6 pins which support the pulse width modulation, which is D3, D5, D6 and D9, D10, D11, 9, 10 and 11. Only these pins will support. But as our kit is having other peripherals also connected to various SPI buses, I2C buses, etc. So I prefer using this D3. If at all you want to use any one like 5 or 6, you can remove the jumper clip here, which is connected to stepper motor. You can use that pin with the help of the female connector. Right, so we can see the pulse width modulation happening over here on the LED, and also we can see using a CRO, cathode ray oscilloscope or digital storage oscilloscope, whatever it may be. Okay, so we have a CRO here. Using CRO we will be watching the waveform also. Now as usual, you select the pins and then it is actually analog write, simple coding, analog write pin 3 map analog read A2, means we are reading the A2. A2 is basically the pot. This pot is connected to A2. You can see this is A1 thermistor, this is A0 LM35, and the other one, which is the port 1, you can see port 1, that is the pin mentioned as A2. Port 1 mentioned as A2. So port 1 is connected to A2. So we are reading it at A2 and we are mapping the values. Generally if you read analog, you get 0 to 1023, which is a 10-bit ADC value. So this value we are mapping to 0 to 255. Our pulse width modulation, this analog write, happens only in 8-bit mode. So you can have up to 255 steps of 5 volts. So starting from 0, you can go up to 255. You can divide the 5 volts into 255 steps. So we are changing the analog read, which is 10-bit. 10-bit means 0 to 1024. 0 to 1023, total of 1024, and we are mapping it to 8-bit, which is 0 to 255. We are giving a delay of 5. Just it reads the pot and sends the values to the LED, pulse width modulated LED. Now hit the upload button by selecting the appropriate ports. So when you hit the upload button, the process starts here. It takes some time to upload. After successful uploading, it will take a while. Please be online. After successful uploading, you see this LED glowing. Actually the LED is not glowing now, but after successful upload only, yeah, it's now done uploading. And please pay attention here to the LED. The intensity of LED can be controlled with the help of this pot. Please observe both of them. When I reduce this, you can see the intensity is going down. When I increase it, You can see this pot is totally controlling the intensity of LED. Not only this, if you want, you can see the voltage that is obtained here. So we can just lift off this clip and we can insert a CRO probe. So I am putting the CRO probe here. So I am putting my CRO probe here at the pin. Yeah, it got locked. And you can see when I am increasing it, you see the intensity is increasing and decreasing. And please try to observe what's happening in the CRO. When I am reducing it, the duty cycle is changing like this. Let me change the waveform, time period change. Please observe this. This is the waveform with some duty cycle, and when I am changing it, when I am adjusting it, you can see the waveform is changing. The duty cycle is increasing, decreasing, increasing and decreasing. So when the waveform is increasing and decreasing according to pot, the intensity also changes like this. See, this is the lowest intensity. Here you see nothing, no waveform is coming over there. And you see here some dullness is there, and you can see the waves with about 20% or maybe less than that duty cycle. And when I increase it further, the glow further increases, and you can see the duty cycle has slightly increased. When I increase it further, see, it's approaching almost 50% duty cycle. And when I increase further, you see the waveform is fully getting 100% duty cycle, and you see the LED is totally glowing with full brightness. So this is about the LED control with pot, which is using the pulse width modulation. There is another sketch also possible. Without controlling with pot, you can upload the other sketch also. Let me show you. This is other possibility. See, LED fading effect, ramp waves, etc. are there. I am showing you the fading effect. Here the LED starts glowing, diminishing, glowing, diminishing, like that. Waxing and waning of intensity happens here. So same port, same pin. Here we are writing the analog value. First we try to increase it from 0 to 255. That shows the rise in intensity. And then we try to reduce it from maximum to minimum. That shows the fall. So you see a fall and rise in intensity. Let's upload the sketch. And see, still the code is running. It is based on the pot only. Once if I upload the sketch, once if the uploading process is over, then I'll be able to see the glowing and diminishing intensity of the LED without any pot. See, now I am showing you this. See, the intensity is falling, increasing, falling, increasing. Now the same thing can be seen on CRO. See, the duty cycle is increasing and decreasing using software. We are increasing and decreasing it using software. And remember, no pot is used. Even if I adjust it or if I completely turn it back, see, the intensity has nothing to do with my pot. My pot is free, but the intensity is decreasing and decreasing, increasing. So it is done with software. This is another kind of wave, which is the triangular wave, basically rising and falling. And another effect is also possible, which is actually this flicker effect. You can see LED lamp flicker effect. That is another code, which I'll upload in a moment. Here we use a random number to have a random intensity. So the intensity is not going to remain constant. You see a light flickering like effect. Of course, it's uploading. It takes few seconds. After successful uploading, you see the lamp gets the LED gets a lamp like flickering effect. Now it's uploading. See, it's just like normal light, a candle when flickers, that kind of flickering effect is seen here. And when you see in the CRO, see, the waveforms are having continuously varying duty cycle, totally random duty cycle, right? This is the example for pulse width modulation with Arduino. Thank you.